Hi everyone, in today's lesson we're going to talk about how to convert exponents to radicals and vice versa. And we're going to use this diagram of a tree with roots below the surface to help us. So what the rule is, it says x to the power over root is equal to the root of x to the power. Okay? So for example, there are many common conversions. So we'll start with x to the 1/2, x to the 1/3, and x to the 1/4. These are the most common radical conversions that we know. So if the root is on the bottom, just like the roots of a tree are on the bottom of the surface, then this is the square root of x to the first, or of x. If the 3 is on the bottom, the 3 is the root, so it's the cube root, that's what we say if it's there, cube root of x to the first. And then here we have the 4th root of x. So memorizing these common conversions will be helpful later on. So let's use the power over root rule to help us simplify these equations here, 1 through 4. So it's always power over root. So this is the 3rd root of 9 squared. Remember, the root always goes here and the power goes here. Alright? Now, again, it's power over root. So this is the cube root of 1000 squared. Okay, now number 3 is a little bit tricky. And number 3 is tricky because it's a negative exponent. You always want to make the exponent positive first. Okay, so this would be 1 over 32 to the 3/5 power, right? Because we can bring it to the denominator to make it positive. And then we could use the root and power. So the 5 is the root and the 3 is the power. So the answer is 1 over the 5th root of 32 cubed. So here would be my final answer. Okay, now number 4, this is the root on the bottom, 2 is the power on top. So this is the 3rd root of -8 squared. This should be in parentheses. Okay, let's see if we could do 5 through 8 now. So again, for number 5, it's power over root. So this is the 3rd root of 16ab squared. But this whole thing is being squared, so that should be in parentheses like that. Okay? Now number 6 again is a starred question because it's got a negative exponent, so does number 7. So we want to make them positive first. So we bring it downstairs. To the positive power. And then we have 1 over the 4th root of a squared minus b squared to the first. Because remember, it's root and power. See if you could try number 7 by yourselves. And then hit resume when you're ready. Alright, the first thing you needed to do was make the exponent positive. So it's 1 over a minus bc to the 2/5 power. The 5 is the root, the 2 is the power. So it's 1 over the 5th root of a minus bc squared. Okay, now number 8 is a little bit tricky too because the negative exponent is on the bottom. So this is another starred. We got to bring it up this time to make it positive. So 5 times x squared minus 5 to the 5/7. 7 is my root, 5 is my power. So it's 5 times the 7th root of x squared minus 5 to the 5th power. Now, we're not necessarily simplifying any of these answers. Maybe we'll do it in class tomorrow, but for right now we're just going to leave them as root and power. Okay, now let's see if we can go the reverse way. So let's write the rule first. So remember, it's x to the power over root is equal to the root of x to the power. Okay? So we have, this is red, the 4th root of 3, or the fourth root of 3 to the 1st. So it's 3 to the 1/4 power. Now this one again, number 2, is read the 5th root of 2 to the 3rd. So it becomes 2 to the 3/5. Remember, the root jumps down on the bottom. Now number 3 is kind of 2 steps. Let's simplify the inside first. So this is the cube root of 9 to the 1st, which is 9 to the 1/3. And then we're going to raise that to the 4th power. This here is a common conversion. If we remember, the cube root of a number is the same as 9 to the 1/3. Okay? And then the rule says I can multiply these two exponents, so it's 9 to the 4/3. When I multiply 1/3 times 4, I get 4/3. Alright, now number 4 is the same concept. Radical 5 is a conversion, common conversion. It's 5 to the 1/2 because it's the square root of 5 to the 1st. And I want to raise that to the 3rd power. Then I can multiply these two. So 1/2 times 3 is 3/2. Okay, now let's jump to number 5. Now, you see how all of this under here is under the radical? This is a square root. So we have to take all of this with a common conversion and raise it to the 1/2. Same with number 6. It's all under a 1/2. This is all under a 4th root, so we need to raise it to the 1/4. This all is under a 1/3, so we all have to raise each of them to those common conversions. So all we do is put the 64, a to the 4th, b to the 6th, put the inside in, each one. A squared minus 9 squared. Now we can simplify them if we want. We know how to distribute these powers in. I mean, we don't have to, but we can. So what is 64 to the 1/2 power? Take a minute, pause the video, and put that into the calculator. 64 to the 1/2 should give you 8. And then we have a and b. And what do we do with these powers? We multiply them. 4 times 1/2 is 2. 6 times 1/2 is 3. So that could be our simplified answer. Same thing with number 6. We'll distribute the power in by multiplying. So we'll get a to the 3/2 and b to the 3rd if we multiply them. Okay. Now we don't have to, like I said, do this, but I just wanted to for a few of them. Alright, last but not least, let's see if we could do the last ones, 9 and 10. So 5 is the root, and 3 is the power. So it's x to the power over root with a 5 on top. Now it's more proper to write it as one term, so we're actually going to bring this up, and this is going to be 5x to the negative 3/5. This would be most appropriate to write it this way. Now this is all under the 4th root, so x to the 5th, y to the 3rd is being raised to the 1/4 power, and the 7xy on top, and then just bring it up. So 7xy, x to the 5th, y to the 3rd, to the negative 1/4. And these are being multiplied together. Alright, take a minute and jot down any questions that you might have and ask us tomorrow. Alright, have a good night.